All right, hello world. Welcome to the Term 2 kickoff. Today is a really big day. Opening round of the Sweet 16 tonight. Number 4 West Virginia taking on Gonzaga. I have West Virginia going to the Final Four, but hard to root against Gonzaga. More importantly though, we have Term 2 of the self-driving car Nanodegree starting, and we are really, really glad that you are studying with us for this term. I think it's going to be a lot of fun. This is where we get into some of the really hardcore robotics that make up how to build a self-driving car. And all 3 of the modules in this term, sensor fusion, localization, and control, are being built with us with a really deep collaborative partnership with industry partners. So sensor fusion and localization will be taught by our partners at Mercedes-Benz, and control will be taught by our partners at Uber Advanced Technologies Group. And you're going to learn a lot of really neat stuff that will help you when you want to go out and perhaps get a job in the field, or if you're just looking to build a self-driving car or work in other areas of robotics. So I want to walk you through the classroom, just show you a little bit of what the term looks like. It'll be pretty familiar to you if based on what you've been through in Term 1. Not a lot has changed. Obviously, the content's all new, and so we'll talk about that, and we think it's pretty exciting. Hopefully you do too. So let's start with a quick tour of the classroom. So you can see this is Term 2. This is my account. You should see something similar when you log into to the classroom. If you see Term 1, just click on this little hamburger menu bar over there and make sure to click on Term 2 here and select that. So you can see this term is all about sensor fusion, localization, and control. We start out with a quick introduction. That is not the most flattering picture of me that's ever been taken, but we have a neat introduction, and then we dive right into sensor fusion. Sensor fusion is all about how do you take sensors on the car like radar and LiDAR and take all that data and fuse it together. It might sound kind of easy, but in fact it's actually a real challenge. The radar might tell you that a car you're tracking is in one place, and the LiDAR, that's lasers, might tell you that the car's in another place, and you have to fuse that data together and try and come up with a coherent picture about where pedestrians and bicycles and other cars and objects are in the real world. It's a nice kind of transition from computer vision, which is obviously another really important type of sensor that you dealt with in Term 1, and now you're going to learn how to deal with radar and LiDAR in Term 2. So we'll introduce you to sensors. We'll talk a little bit about Kalman filters, which is a mathematical technique to combine data like I was just talking about. You might get a bunch of different data measurements from different sensors that show an object you're tracking to be in different places, and you want to think about how do you combine that data to form a coherent picture of the world. And then this is, I think, really important, particularly for those of you who are looking to get a job in the industry. We're starting Term 2 to introduce C++. So initially we're going to try and make it a pretty gentle on-ramp. You're going to do your first version of a Kalman filter in Python, which is a language you should be pretty familiar with by this point. But then we're going to have you do the same thing essentially in C++. So you'll already have a sense of how to build a Kalman filter in Python, and then you'll just do it in C++. And we have a C++ checkpoint, actually part of a larger C++ class that Udacity is building out that'll be free to the world to help you get started with that language. And C++ is a really important language for automotive development. A lot of the job interviews that you might go through if you're interested in working in this field will be in C++. It's a high-performance compiled language that is kind of the default language for the automotive industry. So you'll start to learn about C++. You'll build your first Kalman filter in C++. Then you'll build, excuse me for scrolling around so much, you'll build an extended Kalman filter in C++. So we'll start with a basic Kalman filter, which is like imagine a car moving in a straight line or an object we're tracking moving in a straight line, but we get different measurements about where on that line the car is. That's kind of a basic Kalman filter. An extended Kalman filter is nonlinear data. So imagine a car moving through a turn, and you get different measurements about where that car is as it's moving through a turn. It takes a little bit more advanced math to fuse all that data together into a nonlinear trajectory. And then the final lesson of the sensor fusion module is something called an unscented Kalman filter. This is a really advanced technique that I think a lot of hiring managers will be really impressed by, that you're able to come in and talk about building an unscented Kalman filter. It's a probabilistic technique, a sampling technique for again, measuring where objects are as they move on a nonlinear path, but it has a lot of advantages over the extended Kalman filter. It's something that's only been developed in the last couple of decades, which I guess it's not that recent, but it's a pretty new and exciting technique and pretty advanced. So that's the sensor fusion module. You'll wind up with the unscented Kalman filter project at the end. Lesson 9, or the next module in term 2 will be localization. It'll be particle filters. So if you've taken Sebastian's AI for Robotics class, you'll have some sense of what a particle filter is. It's a way of localizing your vehicle in the world. So sensor fusion is about taking radar and LiDAR data and fusing that together into measurements about where something is. A particle filter is about taking those measurements and then using that to figure out where am I, where is my vehicle on a map or in the world. And we're going to start with Sebastian's lesson on particle filters, but then we're going to move into a really neat project where we build a particle filter in C++, and you deal with a lot more challenges than you had to deal with if you took the AI for Robotics course, having to do with noisy data and other issues in building a particle filter. And this, again, is taught with our partners at Mercedes-Benz. They're really terrific. We'll be launching this content actually in the next couple weeks. It's not yet released, but it will be by the time most of you all are ready to complete the localization module. The final module is control. So we're going to start out with PID control, which again is another topic that you'll be familiar with if you've taken the AI for Robotics class. PID controllers are kind of the fundamental controller in mechanical control theory. And this is all about how do you actually actuate the vehicle. Actuation is like using the steering and the throttle and the brake to control the vehicle and get it to go somewhere. So we might say, you know, we want the vehicle to go at 60 miles an hour, but figuring out exactly how you hold the vehicle steady at 60 miles an hour is a little bit tough. And you can actually see this if you drive on the highway and try and get your car to stay at a solid 60 miles an hour. For those of you outside of the US, call it 100 kilometers an hour. It's hard to get it to stay right at that level. If you use cruise control, then it becomes easier, and that's because cruise control uses something like a PID controller to keep the throttle and the brake aligned at a whatever speed level that you set. So we'll start with a PID controller, not just for speed, but also for steering. We'll be back in the simulator. If you remember the simulator that we used in the behavioral cloning project, we'll be doing something like what you did with behavioral cloning, but using a PID controller instead of using a deep neural network. Most self-driving cars that you see out in the world today are actually built using this kind of robotic stack of sensor fusion, localization, PID control. There are a lot of people doing research to see if deep learning can be used to drive cars, but so far the technical stack for autonomous vehicles really is kind of what we're walking through here, and control is a really important part of it. After PID control and the controller project, there'll be other lessons and projects that we're building out right now about advanced control techniques, linear quadratic regulator, model predictive control, which are advanced techniques for controlling a vehicle's steering, throttle, and brake to move it along a trajectory. So that's term 2. As I mentioned, this is all really exciting, really hardcore robotics. It's all in C++, which is a big advantage if you're looking to move into the industry and you're going to be interviewing with companies. Most of them think C++ is a really important skill. In fact, we had a hiring event here at Udacity a few nights ago with with Bosch, the world's largest automotive supplier, and students ask them a lot of questions about what are the most important skills to know when working with Bosch. And Bosch, Angela Klein, our partner at Bosch who is here, made the point that there are individual skills you need to know for different jobs, but the overriding skill that you really need to know to work at a company like Bosch and many other companies is a really good familiarity with C++, because that's the language that they use. So we hope we're serving you well by teaching you that content this term, and we're excited to go through the term with you and see how you like it. So to cover a few other things, most of the logistics of the course are very similar to what you went through in term 1. There are suggested due dates for each of the projects. Those are good for helping you and us make sure that you're on track. The only hard deadline is the end of term deadline for passing all of your projects. All of the resources that you used, or most of, I guess I should say, almost all the resources that you used in term 1 are still available in the same form in term 2. The Slack community is the same Slack community that you used in term 1. There are already students from the October cohort who are active working on term 2 projects in that Slack community. You'll have a mentor just like you did in term 1. You may have a new mentor because not all mentors continued on, but you'll still have a mentor. The forums, we're moving over to Udacity's standard forums. We tried an experiment with the Confluence forums that you saw in term 1. We decided to move back to Udacity's standard forums that are at discussions.udacity.com. And again, there are already channels there dedicated to the term 2 lessons and projects that you can dive into and take advantage of. We're moving away from Facebook and moving things more onto the Slack community, so that's probably the biggest change, along with the forums being on our discourse platform at discussions.udacity.com. There are a lot of things that we're going to start to do with you now with hiring partners. Now that you've completed term 1, there should be an email going out shortly helping to connect you with hiring partners, trying to get a sense of what jobs you might be interested in if you're interested in a job in this field. So keep an eye on your inbox, because that, as we like to say, is kind of our guiding star in the program, is to help get you into a job working with autonomous vehicles. And now is the time when we start working with you really closely to do that. So that's term 2. We're continuing to work really hard on it. We've got most of it cranked out, but we're still working on the very end of the localization module and the second half of the controls module. It should all be ready by the time that you're ready to tackle it. We think it's really exciting. We really like the projects that we came up with for this term, and we're really grateful to the partnerships with Mercedes-Benz and Uber Advanced Technologies Group. They've put a lot of time into helping to teach students how they work on autonomous vehicles, and they care a lot about this, so we're really grateful to them. And you'll see a lot of them in the videos, so enjoy that. So with that, I would love to take some questions. We have a little bit of a new live stream format today. My colleague Hezekiah off camera is going to kind of shout some questions at me, and I'll field them. Or I don't know if there's a better way to do it. Hezekiah, your call. You can Slack them to me. Okay. All right. Hezekiah is going to Slack them to me on our internal Udacity Slack channel. Let me get all set up on Slack. Incoming. So you can send us questions through the YouTube channel. I actually don't have YouTube set up on this computer. We have a more complicated setup today than usual. So if you send the YouTube questions to Hezekiah, Hezekiah is going to pull them and send them over to me. Oh, and I don't have the names of who's asking the questions, but thank you for whoever asked this question. Oh, Hezekiah tells me it's Sovit Gupta asks, why are there 2 different Slacks, CarND and ND013? Are there different purposes to both of these Slacks? Yes, there are different purposes to each of the Slack communities. So there is a student-only Slack community. That's the carnd.slack.com community. And then there is a self-driving car Slack community that's open to the whole world. Anybody who wants to participate, whether or not they're a Udacity student, that is the nd013.slack.com community. It's a little confusing that we named the public Slack community after our internal code for the self-driving car Nanodegree. It's historical, but that's what they are. A lot of the people in the ND013 Slack community are maybe interested in the open source self-driving car project that Udacity is building, or something like the Diddy challenge that we've published to the whole world, whereas the students in the carnd.slack.com community tend to be quite focused on the self-driving car Nanodegree program and questions about the lessons and projects in that program. I try to be active in both communities, but I do spend quite a bit more of my time in the student Slack community. So if you have a question for me, that's probably the best place to message me or some of the other members of the Udacity team. Mandar Joshi asks, are there details on the environment needed for the projects for this term? Yeah, so we made a decision early on to be IDE agnostic, editor agnostic for this term. So unlike in Python, where there tend to be a lot of packages and you use something like pip or Anaconda to manage packages, in C++ you tend to use things like makefiles and CMake files. And often those are built into an editor, so if you're using something like Visual Studio or Eclipse, those are often built in. We decided to try and make ourselves as editor agnostic for this project as possible, so a lot of the libraries that you'll need are actually folded into the GitHub repos for the individual projects, and you should be able to just build the projects using the CMake file that we leave in the repo for you. We're also building a lesson in our overall C++ course about using build tools like Make and CMake in order to build your projects. Let's see, Chow Wang asks, will there be a starter kit provided for the environment? That's kind of a similar question. We haven't had that issue so far because, again, or we haven't felt like there's a need for a starter kit for term 2 because, again, for C++, we're kind of building all that into the CMake files for the project. You'll learn more about CMake as you proceed. It's a way to basically compile your code across different platforms, and that's kind of become our starter kit in a sense, that and GCC, G++, which is the compiler for C++. But if it seems like as we go that there's a need for that, we will see if there's a good way to create a starter kit. There aren't environment managers for C++ that quite match what pip and Anaconda are for Python. Besthenix asks, is there any CUDA lessons to learn to run on GPU? There isn't really anything to run on a GPU this term. Most of the algorithms that you'll be running this term you can run just fine on your CPU. As you move into industry, you might find if you focus on one of these areas, you might find a need to try and accelerate computation by using something like a GPU or an FPGA, a field programmable gate array. It's another piece of hardware you might want to accelerate an individual algorithm on. But there aren't great kind of cross-platform libraries for accelerating things like sensor fusion, the way there's cuDNN that accelerates TensorFlow and Keras. So we won't be using GPUs this term. Udacity does have a great course on parallel programming. It's an open free course if you're really interested in how to write CUDA directly. I've taken the course, it's terrific, and it's out there for free. You can check it out yourself. Let's see. Somebody asks, are there any chances of hiring companies to hire students in term 2, or will that only happen in term 3? Oh, I think that's Pikai. We are actively trying to match students with hiring partners, whether they've completed term 1 or whether it's later on. We have hiring partners that are really interested in hiring out of the program right now. And so you'll be receiving an email in the next couple of days from our careers team asking you to fill out some information about what companies you're interested in working for, where you're interested in working, and they will be sending your Udacity profile, among other things, to hiring partners. So if you're interested in a job in this space and working with our hiring partners, make sure to complete your Udacity profile. You can find that at profiles.udacity.com. And that profile lists things like your LinkedIn profile, or it links to your LinkedIn profile, your GitHub profile. It lists your Udacity projects. And it's one of the things we send to partners to try and help sell you to our hiring partners. When I say sell, I don't mean for money. We're not we're not collecting a fee. We very much want you to go work for our hiring partners, and so we want to present you in the best light that we can. Let's see. John Gyro asks, is there any deep learning or machine learning content in term 2? Deep learning we covered in term 1. There'll be an advanced deep learning module as an elective in term 3 if you're interested in that. There will be some machine learning in term 2 tied to how to tune parameters. But it won't be some of the heavy-duty machine learning that you saw in term 1 with deep learning and computer vision. This is really more of a robotics-focused term than a machine learning-focused term, although the two overlap and you can use both skill sets to kind of complement each other. Jean-Francois asks, how many students started and completed term 1? What is the success rate? So what we saw, and actually I'm working on a blog post I'm trying to that covers a lot of this. I'm trying to make sure everyone in Udacity is comfortable with it. But at a high level, what we saw is about half of students in both the October and November cohorts successfully graduated. Most of the students who did not not graduate, completed the terms. Most of the students who did not complete the terms, meaning pass all 5 projects by the end of term deadline, most of them we lost pretty early. There weren't a lot of people who completed, say, 3 or 4 projects and it didn't quite make it to the end. And the folks who are in that situation have an extension that they can use, a 4-week extension that they can use to get all 5 of their projects completed and move on to the next term. What we saw is, the folks who didn't wind up completing the term, we often lost pretty early on, and the folks who stuck with it, almost all of them did complete, and it was about half of each class. Musad asks, just wondering if the simulator in the last project will be available for public use. Thanks again for the great work in preparing these courses. You are welcome. That's very kind of you to say. Yes, the simulator will be available for public use. As you might have heard, we open sourced the simulator that we use for deep learning. We intend to open source the simulator that we use for the control project, and it looks like we'll also probably use that simulator for path planning in term 3 and perhaps for other things. We'd really like to keep all of it open sourced. Sometimes there are libraries that we'd like to lean on that are closed source, and so we wind up spending some time trying to figure out how to work around that. And it might mean, in the meantime, publishing some version of the simulator for some project that isn't immediately open source. But in general, it's our goal to open source all of the simulators. Jeffrey asks, can we take multiple electives in term 3? I don't know what they all are, but I'll be interested in taking multiple of them. That's terrific. We would love for you to take multiple of them. We are trying to figure out exactly how we do that. It will probably involve some cash changing hands to help us keep the lights on, but we definitely don't want to exclude you from electives that you would like to take, and so we're working on figuring out exactly how we do that. Chow asks, will Udacity create a group on Facebook for this cohort like before? The answer to that is we will not create a Facebook group. We created a bunch of different communities or tried to build communities in a bunch of different places for term 1. In many places it worked really well. The Slack community is kind of overwhelming, but it's also been a really great source of community and support for students. We found with Facebook, in surveying students and measuring the engagement on that particular platform, it wasn't as helpful, and so we're moving away from that. No knock on Facebook. Facebook's terrific. It's just, there are only so many students and they can only be in so many places at once, and it seemed like the forums and Slack and mentorship were kind of the things students really valued. John Gyro asks, when do we have to have our CVs ready in the Udacity profile to get considered for hiring partners? So the answer is that basically starting from now on, we're going to start trying to match you with hiring partners that we think you might be a good fit for. As I mentioned, you should see an email in the next few days from our careers team asking you to indicate whether you're open to us connecting you with hiring partners and to update your Udacity profile. So I would say if you don't have your CV ready right now, it's probably a good idea to get working on it using the resume resources that are in term 1 of the program. We'll also, I think, include those in term 2. and you can go ahead and have your resume reviewed by a project reviewer, just like your behavioral cloning or traffic signs or lane finding projects. You can send it to a reviewer who will mark it up and send it back. I actually did that myself. I found it really valuable. I'm not actively in the market for a job, but I wanted to kind of see what it was like, and I sent in my resume, and they said, yeah, you use 2 columns. You should only use 1 column, and try and keep it more snappy. And there were even more specific suggestions than that. So I found it really helpful. Let's see. Sarish asks, is Udacity planning for a full-fledged C++ course? Can we get early access to it? The answers are yes and yes. Udacity is building a C++ course that will be free to the world, like many of our free courses. It will be, I think, a terrific tool to support not only the self-driving car program, but also our new robotics Nanodegree and other programs that we're hoping to launch. It'll be a great standalone course on its own. A lot of the contents of that course are already baked into Term 2 of the self-driving car program. I mentioned, or I think I might have screen shared the lesson that we call a C++ checkpoint. That's a big chunk of our C++ courses folded in there. But if you'd like early access to the entire C++ course, if you just ping Stephen, just at Stephen on Slack, Stephen Welch is our course or our services lead. Stephen can help you get connected to the early versions of that C++ course. It should roll out to the whole world in the next few months. Raphael asks, does the localization module include mapping as in SLAM? The localization module does include a map. It does not include SLAM. We're thinking of building SLAM as an advanced localization elective. If you've taken Sebastian's AI for Robotics course, there's actually a little teaser at the very end of that free online course about a basic version of SLAM, and we'd love to do a more in-depth version of that. It turns out that as we're just building out the particle filter project for the localization module, it seemed like that was pretty beefy all on its own, and so we've saved SLAM for an advanced elective. Okay, Hezekiah says that's all the questions we have time for today. But we are really, really excited that you, first of all, completed Term 1. That is a real accomplishment. We've heard from a lot of our hiring partners just how impressive the projects that they've seen on Medium and on blogs and on YouTube and on Twitter have been, and how intense the program is. We know students are spending a lot of time on the program. We're trying to reduce that a little bit. We don't want to burn anybody out. But we also know it's an incredible accomplishment to have gotten through all of those projects and have learned all of the different skills that you needed to complete Term 1. And we're really excited that you stuck with us for Term 2, and we hope that you like Term 2 as much as we hear that you like Term 1. And if there are things that aren't right, let us know. We want to make them better. You guys are our partners in building this, but we hope you're really delighted by the content and the projects. See you in class.